Hi everyone. So before starting this video, I just want to discuss a few things. So first one is that this video is targeted only for ECE student. If you are someone from electrical, then this is not in your syllabus. You can skip this video. Now, if you are someone who has studied EMFT from our platform only on this channel, if you have studied it, then also you can skip this video because this discussion we have already done. Now, those who have studied from somewhere else, those guys can watch this video. Okay. So this question was asked in GATE examination in 2013, and this question is from Oblique Incidence. There was two part of this question. First one, you need to find the expression of incident electric field, and theta I you need to find, and in the second one you need to find the expression of reflected electric field. So the answer of this question is absolutely correct. This is very easy question. This is absolutely correct. But here they are asking the expression of a reflected electric field. So answer given by a lot of educator, and in the PYQ book as well, I have seen a lot of notes as well. Everyone is giving this answer. My point is none of those are correct. Okay, and I will prove this point. I will give the complete explanation why this is not correct. I will prove it using the formula as well. I will prove it using the boundary condition as well. Okay, so have the patience, just watch the video. First one is very easy, everyone can solve it. We will also solve it, but before starting the solution, let's look at a very important point. I am not even reading the question as of now. Okay, so we are just going back to the derivation part. We are going back to that derivation part of oblique incidence. Okay, and what kind of polarization is there? Parallel or perpendicular? Electric field, incident electric field, reflected electric field, and transmitted electric field. All these three fields are in the plane of incidence. I hope you know what do you mean by boundary plane, what do you mean by plane of incidence. So all these three fields are in the plane of incidence. That means this is the case of parallel polarization. So here we are going to discuss only the parallel polarization. So how do we derive the formula for parallel polarization? This is how we derive the formula for parallel polarization. This is the formula for reflection coefficient, and this is the formula for transmission coefficient. So this is the formula that we derive: neta 2 cos theta t minus neta 1 cos theta I divided by neta 2 cos theta t plus neta 1 cos theta I, and the other formula for transmission coefficient. But when we derive the formula, there is a very important point. The point is that you have derived this formula for a particular assumption. This formula is not always true. This is derived for a particular assumption. And what is the assumption? The assumption is that incident and reflected magnetic field will be in the opposite direction. What do I mean by that? Let's just say this is my incident electric field. I am saying that this is my incident electric field. This is my incident wave. This is my plane of this is my incident wave. This is my boundary plane. So incident, this will be reflected and this will be transmitted, right? Incident, reflected, transmitted. Now on this incident wave, this is my incident electric field. Okay, this is my incident electric field. So where will be my magnetic field? E cross H should give me the direction of propagation. Basically, this is my direction of propagation. So where will my magnetic field? E cross H should be towards me. So this is my incident magnetic field. Now, if I am saying that this is my reflection coefficient, if this is my reflection coefficient, so I have assumed that this is the direction of my reflected magnetic field. Then only this formula is true. If I assume that this is my incident magnetic field and my reflected magnetic field is also towards me, if both directions are same, then the formula will take minus sign. Are you getting this point? Okay. So there is an assumption while deriving this formula. And if this is the direction of your reflected magnetic field, then what will be the direction of your reflected electric field? That would be E cross H should give you P. That means this should be the direction of your reflected electric field. So this will be your reflected electric field, and certainly this is the direction of your reflected wave. Okay, we are not talking about the transmitted wave because that is not asked. Okay, if we need to show the direction of transmitted wave, then certainly this and this orientation will be same. So this will be my transmitted wave. Okay, and this will be my transmitted magnetic field. Right? Now this is the formula we have derived. So this is how the formula is derived for this particular case. Now we can relate it with the normal incidence as well. In normal incidence, what do we do? That this is my boundary, right? This is my boundary plane. This is my boundary plane. Incident wave will come and it will be reflected back and then it will be transmitted. So there is also there is one assumption. If I assume that this is my incident electric field, if I assume that this is my incident electric field, then my transmitted electric field will also be in the same direction. Then only this formula is correct. Then only this formula is correct. Neta 2 minus neta 1 upon neta 2 plus neta 1. This is neta 2 and this is neta 1. So if I say that my incident and reflected electric field both are in the same direction, incident and reflected field both are in the same direction, then only this formula is correct. Or what is the other way of saying it? If this is your EI, then what will be your HI? HI will be towards you, E cross H. So this will be your HI. If this is your ER, then what will be your HR? E cross H should be, HR would be this. So one way of saying that this formula is true only when incident and reflected field are in the same direction, or incident and reflected magnetic field are in the opposite direction. So here what we are saying, that incident and reflected magnetic field are in the opposite direction. Now can you relate this diagram to this diagram? Yes, we can relate. What we can do is that try making this theta equals to 0. If you want to make this theta equals to 0, what you will do? So here what is the scenario? Let me take another pen. Okay, so this is the incident wave and this is the electric field. If I want to make theta equals to 0, then what I need to do? I need to make my wave something like this. Basically, I need to pull this upward if I need to make theta equals to 0, because in the case of normal incidence, your theta is equals to 0 only. So if I take this arrow like this, this is how the arrow is coming, right? This is how the arrow is coming. But if I take the arrow like this, then what will happen? Previously, here there was 90-degree angle, right? Here there was 90-degree angle only, right? If I have made the arrow like this, then also between these two, the angle is 90-degree only. Previously, this was the case. Angle was 90-degree. Now I have made the arrow like this. Then also the angle is 90-degree only. So this thing is 90-degree only. Now what about the reflected case? What about the reflected case? You need to make this angle also equals to 0. Then what you will do? You will push this arrow downward. What is the scene here? The scene is like this, that this is your reflected wave and this is your reflected electric field. What you are doing? You are pushing this downward. Then this is how the diagram will be made, that this is my reflected wave and this is my reflected electric field. This is my reflected wave and this is my reflected electric field. Again the angle is 90-degree only. So this diagram and this diagram both are same thing only. This diagram is the special case of this diagram, and the special case is your theta I is 0-degree and theta R is 0-degree. If theta I and theta R both are 0-degree, that means theta T will also be 0-degree. So if you put 0-degree here, you will get this formula. So are you able to relate the thing? Are you able to relate normal incidence with oblique incidence? Both are the same thing. This is just the special case of that, nothing else. Are you getting this point? Why did I make this analogy? I made this analogy just to prove you that here also the reflected and incident electric field are, we cannot say both are in the same direction. We cannot say that incident and reflected field both are in the same direction. We cannot say it, because one is like this, one is like this. But if I make the theta equals to 0 and if I make theta r equals to 0, I get to know that both are pointing upward. Are you understanding this point? That means certainly magnetic field are in the opposite direction, because here I can directly say that magnetic field are in opposite direction, right? So this formula that we have derived for this condition, right? Now in this particular case, what we were considering, that this is my boundary plane, this is how the wave is coming, this is how it is reflected back, and this is how it is transmitted. Now what if this is my boundary plane? What if this is my boundary plane? So how the wave will come? This is how the wave will come, and this is how it will be reflected back, and this is how it will be transmitted, right? What is the scene? This is the boundary plane. So this is how the wave is coming. This is how the wave is coming. This is how it is reflected back, and this is how it is transmitted. Now what I am assuming? Incident electric field I am assuming in this direction, that this is my incident electric field. This is my incident electric field. Okay. Now I have derived this formula. I have written down this formula. The formula is neta 2 cos theta t minus neta 1 cos theta I. The formula which you usually remember. So if you have written down this formula, then what is the assumption behind it? The assumption is that incident magnetic field and reflected magnetic field both will be in the opposite direction. Now if this is your EI, then what will be your HI? E cross H should give me P. So here will be my HI. Now where should be your HR? both should be in opposite direction. So this is how my HR should be there. This is how my HR should be there. So what will be the direction of ER? E cross H should be P. So what should be the direction of ER? The direction of ER should be this. This should be the direction of ER. Then only this formula will stand correct. Now you can do the same analogy. What you need to do? Try making theta equals to 0 and try making theta r equals to 0. You will get to know that EI and ER are pointing in the same direction. What I am saying, try making theta equals to 0. Then what you will do? This is the arrow. You will take this arrow like this. So if I take this arrow like this, then this is how my EI will look like, right? And what is your theta r? This is your theta r. You will make this arrow like this. So where will your ER go? This is how my ER will go. Basically, this arrow goes here. So this will be my EI. And if this arrow goes here, so this will be my ER. So EI and ER both are in the same direction only. Okay. So then only this formula stands correct. Are you getting this point? Is that clear? Okay. Now let's come back to the question. This was a very important point which we usually don't care. We just remember the formula. But the point is, this formula is true only for some special cases. It is not always true. Right? Okay. Now let's come back to the question. In the first one, we need to find the incident angle. So first let's find the incident angle. How will you find it? Using Snell's law. So Snell's law, what it will say? Sin theta I need to find is equals to under root epsilon r2 sin theta. Okay, let me turn on the charger once. Okay, just one sec. Yeah. So this theta t is given as 19.2 degree. It is already given, right? Theta t is already given as 19.2 degree. So from here you will get to know that if you put these values in the equation, you will get to know that theta I is equals to 45 degree. Okay. So theta I is 45 degree. So this angle is 45 degree only, right? This angle is 45 degree. Now can you write down the incident field? Certainly I can write down. So this is the direction of incident field that they have given. So this incident electric field is having two components. This is in plus AX direction and this is in minus AZ direction. Are you able to understand this point? According to them, this is plus AX and this is, you can see here, this is your plus AX and this is your plus AZ. So what is the direction of incident electric field? Incident electric field is in plus AX and minus AZ. Although by the option as well you can see plus AX and minus AZ, plus AX and minus AZ. So this option is gone. And in the where theta is equal to 45 degree, this is the theta is equal to 45 degree. So only this option is left. These are already cut. And here they are saying that it is in plus AX and plus AZ. So this is also gone. So which option is left? Only C option is left. So this is how you can do this question. But we can do it correctly as well. Let's do it completely. Okay. Let's do the solution of this question completely. So how will I write down the expression of incident electric field? So my first point is to write down the magnitude, that is E naught, which is not given, but from the option I can get to know that magnitude would have been E naught. Then I will write down the direction. What is the direction? The direction is in AX cap minus AZ cap. AX cap minus AZ cap. But if I am writing down the direction, that means it should be unit vector. But it is not a unit vector. If I need to make it unit vector, then I need to divide it by its magnitude. So this job is done. Then what do we write here? E to the power minus j beta z we write, or we can say, what do we write? K dot r. This is how we write down the expression of electric field. What is K? What is K vector? K vector is beta into direction of propagation, right? Direction of propagation of EM wave. Beta into direction of propagation of EM wave. What is the value of beta here? Beta is 2 pi by lambda. 2 pi by lambda. What is the value of lambda here? 6 into 10 to the power 4. 10 to the power minus 4, sorry. So that is pi by 3 into 10 to the power 4. And what is the direction of propagation? This is the value of beta, right? And what is the direction of propagation? The direction of propagation, you can see here, what will be the direction of propagation? So wave is coming like this. The incident wave is coming like this, right? So it has also two components. One component is like this and other one is like this. So wave is propagating in plus AX and plus AZ, right? Wave is propagating in plus AX and plus AZ, right? And what is the angle they have made here? 45 degree. Look here, why did I wrote down under root 2? because the angle was 45 degree, no? Like component was equal in both of the direction. Basically here I should have taught you one more point. The point was, if I am writing down this direction, so here I divided by under root 2 because the thing is, in the incident electric field, this is my incident electric field, right? So here the angle is 45 degree. This angle is also, because this angle is 45, so this angle will also be 45 because this is already 90. This will be also 45, this will also be 45. So this angle is 45 degree and this angle is 45 degree. Now I need to write down the direction. So if I need to write down the direction, then I will assume this magnitude to be 1. So component of 1 in x direction and component of 1 in minus z direction. What that would be? 1 cos 45. That would be 1 by under root 2 ax cap. 1 cos 45 minus 1 by under root 2 az cap. Why minus sign? Because this is in minus z. So that's why I wrote down here under root 2. Now in this case, what is the scene? This is the direction of propagation of wave. I will assume the magnitude to be 1. Now I need to take the component. In which direction I need to take the component? In plus ax and plus az. So what will be the direction? The direction of propagation, or you can write down aki. That would be 1 by under root 2 ax cap plus 1 by under root 2 az cap. Okay. So the direction of propagation is 1 by under root 2 ax cap plus 1 by under root 2 az cap, right? So what is the k value? That is pi by 3. And now directly I will write down k dot r. Okay, directly I am writing down k dot r here. So k dot r would be pi by 3 into 10 to the power 4. This is your AKI. By under root 2 ay cap. And what is your r vector? R vector is ax cap plus ay cap plus az cap. This is the r vector, right? From here what we are getting, whatever that we are getting, you can solve it, right? You can solve it. So from there you will get which option? You will get the option C. You will get the option C, which is very easy. You can solve it. Pi by 3 into 10 to the power 4 will be same. 1 by under root 2. Oh, sorry. Here it would be k dot r, no? So x, y, z I forgot to write. Basically, r vector is x ax cap plus y ay cap plus z az cap. This is your r vector. So what you are going to get? Pi by 3 into 10 to the power 4 x by under root 2 plus z by under root 2. So from here your EI expression is coming out to be E naught by under root 2 ax cap minus az cap e to the power minus j pi by 3 into 10 to the power 4 x by under root, and under root 2 I can take outward, right? Because under root 2 is common. 10 to the power 4 divided by under root 2 x plus z. That's it. This is your EI. So this is how you can get the complete answer. If this question was asked in ECE, then this is how you would be solving it if it is asked in ECE mains, right? Otherwise by the option as well it was very easy. Now the next part is very important. You need to find out the expression of ER. So that I will find out. I will find out with respect to this diagram, because with respect to this diagram I know my formula, which is this formula. Do I know the value of theta? Yes. Do I know the value of theta t? Yes. So what will be my reflection coefficient? What that would be? Neta 2. What would be neta 2? Neta is always proportional to under root 1 by epsilon r. Inversely proportional to under root epsilon r you can say, or proportional to under root 1 by epsilon r you can say, right? So 1 by under root 4.5 cos theta t is 19.2 minus 1 cos theta I, that is 45 degree, divided by the same thing but just the addition would come. Now when you solve it, what you are going to get? When you do this calculation, you will get the value of minus 0.23. This is the value of reflection coefficient you will get. So now the thing is, I made this formula considering that these direction which I am assuming, those are correct only. But if I get the value of gamma to be negative, if I get the value of gamma to be negative, that means the direction that I assumed, that is not correct. The actual direction is the opposite direction. Are you getting this point? If you remember this thing in the normal incidence. So if you get the gamma, let's just say gamma I am getting minus 0.5. That means actually I assumed my direction of reflected electric field in this direction. Actually I assumed that incident and reflected electric field are in the same direction. But if the gamma is becoming negative, what is this? This is your gamma E. So if gamma E is becoming negative, that means gamma H is positive, because gamma E is equals to minus gamma H. If gamma H is positive, what does that mean? That means magnetic field did not change its direction. Magnetic field did not change its direction. So if magnetic field is not changing its direction, then who needs to change the direction? Electric field. Or what you can say, if your gamma is becoming negative, that means the assumption that you made that electric field and reflected incident electric field and reflected electric field will be in the same direction, that assumption is wrong. So if this is how your incident electric field, then reflected electric field will be in the opposite direction, right? So if my gamma is becoming negative here, if my gamma is becoming negative here my gamma is becoming negative, that means I assumed my reflected electric field to be in this direction, but actually my reflected electric field will be in this particular direction. Because why is that so? Because my gamma became negative. If my gamma became negative, that means this will be the actual direction. So in the diagram, what will be my direction of reflected electric field? This will be the direction of reflected electric field. In the given diagram, in the question itself, which direction they have given? They have given this direction only. So what people did, like those who made the solution of this particular question, what they did was, they got the answer to be minus 0.23, right? Then they say that this is the direction that they have shown. And if I am getting the reflection coefficient to be negative, that means this direction I should take, which is absolutely wrong. This doesn't make any sense. Your formula is not derived with respect to this diagram. The formula that you are applying, which is not derived with respect to this diagram. The formula that you are writing, this particular formula that you are writing, that is derived with respect to this particular diagram, right? But in the examination, which kind of diagram they have made? They have shown this is the direction of a reflected electric field. This they have shown in the examination. So you cannot go by the diagram of the examination paper setter. They can make any direction. But which formula you are applying? The formula that you are applying, that is derived with respect to which diagram? First you need to make that diagram. And then with the value of reflection coefficient, you will get to know that what is the actual direction of reflected electric field. So if the actual direction of reflected electric field is this only, then no matter whatever that they have drawn here, that doesn't matter. The actual reflected electric field direction will be this. So answer will be written with respect to that. Okay, and this minus sign doesn't matter at all. It matters only to tell you the direction. So the direction is this one. This I have got to know now. So what it will point towards? So this direction will point towards minus AX and minus AZ. So this is pointing towards minus AX and minus AZ. Did you get this point? Because if you see the question, this is your plus AX, this is your plus AZ. So actually it is pointing towards, if you see, it is pointing towards minus AX and minus AZ. And what is this angle? This angle is certainly 45 degree. You can see the geometry. These angles are 45 degree only. Because theta I and theta are equal. Theta I and theta are equal. Theta I will be equals to theta R will be equals to 45 degree. So actual diagram was this, but you applied the formula, you thought that answer is becoming minus 0.23, so I should invert the direction, which is absolutely wrong. When you are applying the formula, the diagram should be always there in your mind, that with respect to which diagram I am applying the formula. If I have the diagram clear, then without a second thought, without even looking the diagram of the given question, I can make the final diagram, then I can calculate the value of gamma, and then I will actually get to know the direction of a reflected electric field. And that direction is coming same like this as well. Okay, the direction is coming same as this direction. So if it is coming same as this direction, so reflected electric field. So what do you think, what will be the direction of a reflected electric field? Here we have seen this was the direction of reflected electric field. These were the components. Both were at 45 degree. both were at 45 degree. This was your minus AZ and this was your minus AX. And if I am only writing down the direction, forget about the magnitude. If I am only writing down the direction, then what will be the direction? The direction will be, here I will assume the magnitude to be 1. Then I will take the component of 1 with respect to 45 degree in minus AX cap. So that would be 1 by under root 2 minus AX cap, and then 1 by under root 2 minus AZ cap. So this will be the direction. So actual direction would be, this is the direction of a reflected electric field. So actual direction would be minus 1 by under root 2 can come outward, plus AX cap plus AZ cap. So this will be the direction, and that direction is given only in this option. But here magnitude is wrong, right? Now if I know my incident electric field, what was my incident electric field? E naught by under root 2, what was the direction? AX cap minus AZ cap, e to the power minus j beta, that is pi by 3 under root 2 into 10 to the power 4, and here it was x plus z. So this was my incident electric field. So can I write down my reflected electric field? Yes. The magnitude, the ratio of the magnitude of reflected to the incident electric field is 0.23. So if the magnitude here is E naught by under root 2, then here the magnitude will be 0.23 into E naught by under root 2. What is the direction of reflected electric field? The direction of reflected electric, look, here the thing is, the direction of reflected electric field is in minus AX plus AZ cap. AX cap plus AZ cap, but along with that minus sign will also come here. Are you getting this point? Along with that minus sign will also come here. Basically this particular quantity, look, this is the direction only, this is the complete direction only. If the magnitude was E naught, then this magnitude will be 0.23 E naught. And what will be the direction? Direction will be AX cap plus AZ cap divided by minus under root 2. So AX cap plus AZ cap divided by minus under root 2. Here the magnitude was E naught, it was not E naught by under root 2. I said that the magnitude is E naught by under root 2, but no. Magnitude is E naught, the direction is AX cap minus AZ cap divided by under root 2. So here the magnitude is 0.23 E naught, but the direction is AX cap plus AZ cap divided by under root 2 and then minus sign. So which is not available in any of the option. If I had made this thing, then this option would be correct. So here the actual thing is no answer is correct. So that was my point here. Okay. So that's why I made this video. Now we can certainly write down all this thing. Beta value will not change at all. Only the direction of propagation will change. So here you can see the direction of propagation. So if you see this direction of propagation, so here what I can see, the direction of propagation is in plus AX and minus AZ. Previously it was in, direction of propagation was in plus AX and plus AZ. So answer was coming X plus Z. But now it is in plus AX and minus AZ. So answer would come X minus Z. Right? So answer here would come X minus Z. So in the first option everything is correct, just there was a missing minus sign. Now this is the first way of proving this question. I hope you would have understood the 30-minute analysis. Why did I spend 30 minutes here? I hope you would have understood that in EMFT only the final formula is not remembering the final formula is not only important. The important part is to remember the assumption as well. This is just one of the topic, like oblique incident I have taken. Now in EMFT, wherever you have to remember the formula, always remember the assumption as well, that with respect to which assumption you have remembered the formula. Okay, you can like if you have already covered it and you are having only 15 days left for your examination, roughly around 15 to 20 days, then you cannot cover the complete playlist which I have made public on YouTube itself. But if you come back next year, then you can prepare EMFT from that particular playlist. Now this is the first way. Here I have given all the points. I hope that is clear to you. Okay. Now the second way could be using the boundary condition. So for that you can go to this video, problem solving on oblique incident, EMFT, PrepFusion. This you can type and you can go at this hour. So here I am proving this same question using the boundary condition as well. In this video I am not going to prove it because I have already done it. So you can go and using the boundary condition. Here I am not going to apply any formula. No formula will be applied here. By going by the pure concept of boundary condition, we are proving it. Okay, so that you can watch in this particular video. So let me know in the comment section how did you find this video, and do you want more concepts like this, more questions like this which are controversial but not yet exposed. So those questions I can certainly bring. Okay, thank you very much.